The next sorting algorithm that we're going to talk about is called bubble sort. Now, bubble sort is one of the more naive algorithms in that it doesn't require a lot of reasoning or thought to really come up with it, and it's surprisingly effective. So in order to figure out how bubble sort works, we're first going to go back to the XSort lab that we used last time. So if we switch to this XSort lab, now let me start again. So we have the XSort lab set to bubble sort. So essentially, at a high level, the way bubble sort works is that it tries to propagate up the largest element. Now remember in selection sort, we said, okay, if we find the max and we put it at the back. Then we find the next max and we put it at the back again. Bubble sort essentially says, I'm going to do the same thing, but as I find the max, I'm going to keep swapping elements so that the larger one is always towards the end of the list. So what that means is that essentially bubble sort will look at two elements and see the bit that are adjacent and make sure that the larger element is in front of the smaller element. So in this situation, previously, the small element was at number 2 and the large was at number 1. So then it just swapped it. Next, it's going to check these two, and they're already in order because the smaller one is on the left and the bigger one's on the right. Then it's going to check this and swap them. I'll check this. Now when I press next, 5 and 6 are going to swap, right? Because 6 is smaller than 5, so when it compares the two, it's going to say, okay, 5 should go forward. And in this way, we can see that selection sort will essentially propagate up the largest element because the largest element is greater in size than every other element, which means that it'll always be swapped up. And so, if we carry out this pass, so this element is being swapped up, it'll finally get to 12, which is the largest, and now this large element will keep getting pushed up to the top. So if we see this go, and finally we get the large element to the back. So, as we see, in one pass of bubble sort, we got the largest element to the back, and now it's at the sorted location of where it should be. So, we did modify the rest of the list as we went, but it turns out that this is inconsequential. Really, what you should be thinking about is the fact that it's making the largest element go to the back. And so notice how in one pass we basically loop through the list, and so we're going to do that over and over again. So if we see this happen in real time, it keeps propagating up the largest element, and then it'll get to the back. And so it'll keep doing this over and over again. So now that we understand how bubble sort works, let's actually go and look at the algorithm that we wrote in Python. Before we go to the algorithm though, one key thing to understand is that bubble sort does modify the previous parts of the list. And even though we know that this part of the list is sorted, these parts are modified. And so what that means is that there are some instances where the entire list will actually be sorted before we finish all the passes. Like in this case, we already had these parts sorted, and so we didn't have to do any swapping. So in our algorithm, we're basically going to say that if we didn't have to do any swapping, then we know the list is sorted because that means that every time we compare two elements, the larger element was always in the higher index. If that's the case, then that means that the list is sorted. So then we can basically break out of our loop and say, okay, we're done. So now if we look at the code, this is exactly what's happening. So we keep track of a variable swapped equals true, which essentially means that if we swapped elements during that pass. So basically this while loop is basically keeping track of which pass we're at. So the first time we're going to move the first element to the largest element to the back and so on. So we initially say that swapped equals to false because we haven't swapped an element yet. Now what we do is we loop from I up till the end. Now notice how the end starts out at n, and each time we iterate over the elements, we say end minus equals 1 because we know that the largest element is now in the back, which means that the next time we want to only loop through everything except for the last element, then everything except for the second to last element and the last element. So we loop through everything in the list up till the end, and everything after the end being sorted, and we say if a of I minus 1, so if the element before a of I, if that element is greater than the current element we're looking at, that means that we have a larger element before a smaller element in our list, which is not in sorted order. So we essentially swap those two elements, And in order to log the fact that we had to swap an element, we say swapped is equal to true. Thus, when we break out of this for loop, we subtract n by 1, and we say that, okay, swapped was true, we did swap an element, so that means we have to keep trying to sort it. Now imagine if none of this if statement was never hit, then that means that swapped would remain to be false, and so we would break out of the while loop. So a few things to note about this bubble sort. The first thing being is that it doesn't return anything, because we're actually destructively swapping elements in lists, and so it'll eventually destructively sort A. Additionally, note that we don't check for end we don't check in the while loop to make sure that end is greater than 0, because what if we keep subtracting 1 from end and then we get into negative numbers? The reason being is that imagine the case where end is equal to 1. Now if end is equal to 1, then that means that the entire list except for the first element is sorted. However, we know if everything else is sorted and the first element isn't, a list of size 1 is sorted, so the first element is the smallest element in the list, and so the entire list is actually sorted. So, interestingly enough, bubble sort works pretty well on lists of smaller sizes because it has this nice feature where it actually can break out of the while loop, right? If we didn't swap anything, then we're done. This is something that isn't true of the other sort algorithms that we're looking at. For instance, selection sort. Selection sort will always continue to do every iteration that it was going to do, and even if it's already got a sorted list, it's still going to do all the work. However, if bubble sort was given a sorted list, it would basically try to swap one pass, and nothing would be swapped, and so it would break out immediately. So in this way, bubble sort has its advantages. So this was a quick introduction to bubble sort. Definitely, I would recommend going over examples on paper and making sure that you understand exactly why everything is happening, and then try and practice writing it, because that'll get you some experience understanding the real nuances of the code. Next time, we're going to look at merge sort and basically talk about a more interesting algorithm.